as part of Basics of Mechanical Engineering course 2. So, last lecture we went in full detail about rolling, and you are now convinced if you have to make uniform cross section, you can make through rolling process. For example, railway track can be made by rolling process. If you want to make flat sheets, rolling process. If you want to make threads on an object, rolling can be done. Ring rolling can be done. Okay. So, these are all different advancements or variations of rolling process, and generally rolling is a continuous process. Generally, thread rolling is an exception. So, generally rolling is a continuous process. Now, let us get into another process which is called as forming. In forming, what we do is we try to keep a constant volume of material inside a die and try to hammer it from one direction or all directions. The hammering can be done through mechanical, hydraulic, or it can be done through pneumatic. It is possible. You can try to use, depending upon your material property, we use. An impact, sudden impact is given, and the shape of the die is produced on the part, and then you try to get the output of it. Let us take a simple example of a spanner. A spanner can be produced by casting process also. For example, in casting, you try to take a metal, steel, assuming steel you try to take it to a higher temperature, phase change happens, liquid, you pour it into a mold or a die, then you try to get the part. So, there the grains, whatever it grows, starts growing from the mold surface, where there is a gradient of delta t, a steep gradient of delta t. From there, the grain starts growing and it comes towards the center. So, now the directional solidification plays an important role. Whereas, when you try to make the same component through metal forming, the grain growth, new grain distribution, everything happens along the force given direction. So, what is the big difference? The strength properties are very good in rolling process, in forging process, as compared to that of casting. In casting, if I know the weakest direction through which the grains are done, in that direction if I apply force, it can quickly break. And the strength properties are not uniform when you cast a material, or I can put it this way, a casted part cannot be put for mechanical loading in a large extent. It is a generalized statement, there can be exceptions, but whereas in rolling or in forging, what happens, whatever part you make, that part can try to take huge impact loads. With that introduction, let us get into forming. So, here we will start understanding about forming, introduction to forming. Then we would try to do classifications, like there we did bulk and sheet. Then we went into many of those classifications in metal forming, and then when we went into rolling also, we saw different classifications. In the same way, we would try to look at classifications in forging process. Then we will try to understand the forging mechanism, then various hammers, then forging dies. Then we have a classification called as open die forging, then closed die forging. Then forging defects, we will try to recap, and then we try to get the references. Forging is a deformation process in which the work is compressed between the two dies. So, here we assume that there is a top die and a bottom die. So, these are the die 1 and die 2, you have the workpiece here. Right. So, there is a compressive load applied. The compressive load can be gradual also, but when it is gradual, the deformation will not be so fast. So, here majority of the time what we do is we try to impact. So, work is compressed between the two dies using either impact or gradual pressure to form a part. Majority of the time in forging, we try to have impact, sudden load. Again here you can see it is a hot working process. In hot working process, the material gets softened, so the load applied is less and you can quickly deform a large volume. A forging machine that applies an impact load is called as a forging hammer, while one that applies gradual pressure is called as forging press. Look at the difference between hammer and press, right. So, this makes a huge difference. Various components such as engine crankshaft, connecting rod, camshaft, then many of those components, gears are today forged. So, the forged gears has a huge mechanical properties, or it put in service condition, it gives you a huge output. That means to say, without replacement, the repeatability, reliability is very high. It is today we are also making not only spur gears, we are also making helical gears. So, what it does is, it has a die, you keep the block there, then there is a top die which hits, and then while hitting itself, it tries to slightly orient. So, you get a helix there. The helix will not be a full helix, but a small helix is given there. So, today helical gears are forged. Beautiful output you get. The consistency, reliability is extremely phenomenal. Otherwise, we used to do it by machining earlier, but now we do it by forging. The production rate is very high. So, various components such as engine, crankshaft, connecting rod, gears, aircraft structural component, jet engine, turbine parts, all are made through forging. When we look at the history of forging, when they wanted to make sword and other artillery weapons, they used exhaustively forging methods. The forging process dated from the earliest written record of man around about 7,000 years ago. There is an evidence that the forging was used by ancient Egypt, Greece, Persian, Indian, Chinese and Japanese for making weapons, jewelry and various other implements. Engraved stone patterns were used as impression die in the hammering of gold and silver in the ancient time. So, what they did was, they had a die, in that die they used to have all the features whatever they want, and that they will try to impact it on a flat sheet or a coin, they used to have the engraving. In fact, the gold coins of ancient times were all forged, wherein which they had the king's logo or face or whatever it is, right. And then they also had the worth of money, like the coin value, like 1 rupee or one whatever it is, 1 carat, 24 carat, that is all forged. Created around about 1600 BCE, evolved into a fabrication of coin by a similar process around about 18 BCE. More complicated impression dies were made in Rome around 200 CE, and then the blacksmith trade remains relatively unchanged for many centuries until the drop hammer with guided ram were introduced in the end of the 18th century. They were able to use this forging. So, classifications of forging. What are the major classifications? Open die forging, closed die forging. Open die forging means bottom and the top of an object, right. This is the top of the object, bottom of the object. So, if you have features and if all the features have to be brought in the workpiece, then we always go for closed die forging. In open die forging, the basic shape alone will be there. For example, this is a spanner. So, you have the features, the top features are not very important, only these dimensions are important, then we go for closed die forging. Closed die forging are economical. For example, the screwdriver tip is forged, right. So, here the cost of die is very economical, open die forging, closed die forging. In open die forging, we have hand die and powered. Again in power, we have hammer and we have press. Press are gradual, hammer is impact. So, gradual means from the top you can reduce or you can control the feed rates, slowly it will come down and it will go up. So, closed die forging you can have drop, press and you can have machines, right. So, open die is used for components and parts where their geometry is not so stringent and features are not so prominent. In closed die that is not there. The forging hammer. The forging hammer operate by applying an impact load as against the workpiece. So, you try to have a lever, you try to take it to the highest position, from there you drop impact. The drop hammers are used for this purpose. There are gravity based and there are power based drop hammers. Gravity based is you try to pull it up, you put a wheel and then you try to take the weights to the topmost position and then from there you instantly release. It is gravity drop hammers. And power drop is slowly you take it through a power and then you do it. So, these are the different types of hammers which has been there. This is a steam hammer. So, the steam is used to lift the piston to a highest point and from there it is released. It can be through gravity or you can push through steam down and then that can try to deform. The other thing is open frame steam hammer is also there. Then you also have gravity based hammer. So, gravity is you roll it, it comes to the topmost position and then you drop it. Impact forging. So, forging press. Press apply gradual pressure rather than sudden impact to accomplish the forging operation. So, the press can be mechanical press, hydraulic press or it can be screw press. When you try to look into a die, so the cross section of a die is shown. Like you have in casting a draft allowance, you also have something called as outside draft angle. Right? This is the outside draft angle. The inside, this is the inside draft angle which you have, which is given such that the component can be released out. You do not have sharp corners, you have corners wherein which you try to have the end. Those portion are called as corners. This is corner. So, from the main web connecting to the corner, you have something called as ribs. The main one is called as the web. You can see there is a gutter. The gutter size will be always larger as compared to that of your component. For example, when the output of the component will be cut like this. So, this center portion like dumbbell which is there, that will be the product. For this product, they always will have a land and a gutter. The function of the land is to take the excess metal from the main area to the gutter, and the function of the gutter is to make sure that it tries to resist to flow inside this gutter and it gives enough pressure such that the uniform distribution happens in the die. So, later what along with the land it is cut down. So, this part is a waste. So, this projection part is called as a flash, and in between the top and bottom die is called as a parting line. Identifying a parting line for any given component is a big challenge. So, and there will not be any sharp corners, they will always be fillet. So, that is the fillet we give. So, here friends, in a die we have the same thing like what is there in the mold. You will have draft allowance, there we had a shake allowance, here we do not have shake allowance. Here we have a land and a gutter, so through which the filling happens. So, when it tries to flow in this direction, there is enough of resistance. So, the metal distribution happens here inside the die area, there is proper filling of metals. Suppose if I don't give this land and the gutter, you will not have proper filling of the material inside the die portion. So, gutter, you know the function of a gutter. What is flash? The flash will be trimmed, land to gutter, you know fillet which is given, web, and then you know rib. So, all these things will be part of a die. So, open die forging. So, if you look at open die forging, it is something like a compressive load which is applied. So, the workpiece whatever is here, when you apply force, it tries to get bulged and it tries to get reduced. So, this will be there, this will be the start and this will be maybe the end. So, you see here there is a bulging which is happening. Okay. And why is that this phenomena is happening? Why uniform bulging is not happening? What happens is at the top and the bottom, there is a huge friction which happens between the metal workpiece and the die which is made out of metal. So, because of this friction which is there, so this does not allow the material to flow easily, whereas in the center portion the material allows to flow easily. That is why we get this bulged portion while doing open die forging, right. So, open die forging involves compression of the work part of a cylindrical cross section area between two flats. These two flats does not have any geometry. The forging operation known as upsetting or upset forging reduces the height of the work and increases the diameter, because it is a constant volume process. The upset force as a function of height and height reduction h naught to h, the plot is given. Say for here you can see what is h and then what is the reduction we are doing, h naught minus h. What is the forging load? So, you can see there the response of the curve, right. The upsetting force as a function of the height h and the height reduction h naught to h. This plot is sometimes called as load stroke curve. Spanners are open forged. Your chisel, your knife, right, and all the agricultural implants, when the blacksmith hits, it is all open die forging. Okay. So, without friction, what will happen? Under the ideal condition, there is no friction between the workpiece, this is the workpiece, and the die surface, then there is a homogeneous deformation will happen, there will not be any bulging. This results in uniform radial flow of the material through the height. So, whatever is the height reduction, the radial flow will be there, but in reality without friction does not happen. So, assumption, without friction, we are trying to do a small analysis to find out the force which is required. Under ideal condition, no friction force is acting between the die surface and the forged material. Uniform and homogeneous deformation in material happens. So, through true strain curve, we find out the strain is nothing but natural logarithm of h naught by h, and we are trying to apply a force F equal to yield force into cross section area, where h naught is the height of the workpiece, h is at some intermediate point when it is trying to reduce is h, flow stress is given for a corresponding strain is y s. The force whichever is applied is F, A is the area on which the flat surface of the workpiece is getting hit. At the end of compression stroke, the h is a function of hf and the true strain reaches a maximum value. When there is a friction, what happens? In the case when there is a friction, the flow of the material or the metal at the die surface is opposed by the friction. This creates a barreling effect. This is called as a barreling effect. The hotter metal in the middle of the part flows easily, readily than the colder portion which is touching the top surface. These effects are more significant as the diameter to height ratio of the workpiece increases. This is start of the process, this is partial compression, this is final compression. Okay. So, friction and barreling effect you should remember, and what is the cause we have discussed. So, what are the advantage of open die forging? In open die forging, it is very simple. The die is inexpensive. It is useful for small quantities. A wide range and size are available. Whatever is the output, it gives you a good strength. Disadvantages: limited to a very simple shape like a screwdriver, spanner. The bolt head, by the way, gentlemen, the bolt head, this head is made by forging. So, they start with a large material, then there is a force which hits. So, it tries to take some shape like this, then they try to move to another one, and then they try to give an impact shape, so that you try to get a hexagon. This hexagon is formed at the top. So, this is done by forging process. So, machining of a final shape is necessary, because it is open die, it is not a tighter tolerance, sometimes it is necessary. Poor utilization of material can happen, because there can be material which gets oozed out as a flash, then finally you trim, and it needs higher degree of skill. So, now the first one what we did was, we did the analysis without friction. Now, we will try to add friction to the analysis and see how does the analysis change. When performing a hot work part with cold dies, the barreling effect is even more pronounced. The hotter metal in the middle of the part flows more readily than the colder part at the end. These effects are more significant as the diameter to height ratio of the work part increases. So, due to a higher contact area at the workpiece die interface, there is a huge impact of the friction. The applied force here is going to be F is equal to K times Y into A. Y is the flow stress, A is the area, K is the ratio, strength constant. So, mu is the friction. Okay. So, K is again a shape factor. So, that in turn depends on the mu. So, mu is the coefficient of friction, D is the workpiece diameter, H is the height of the workpiece part. So, with that you try to calculate Kf. From Kf you know the flow stress and the area which is there, you can try to calculate the applied load. So, in open die forging there are process types. Fullering process. In fullering process, what happens is, it is accomplished by die with convex shape. So, if you want to have any shape like this, something like this, if you want to have, so then you will try to use the fullering operation, okay, or you can try to have something like this. Like this also you can try to have, right. So, here is accomplished by die with a convex surface. The die cavities are often designed with into multiple cavities and impressions, right. Multiple cavities in the sense like your lost form wax casting, you can have multiple things attached. So, edging is another process. So, edging is it is accomplished by die with a concave shape. Concave, the previous one was convex. Right. This is called as edging process. Cogging process. Cogging process, it is a sequence of forging compressions along the length of the workpiece to reduce the cross section area and increase the length. For example, it taps here, it keeps moving. Okay. Sequence of forging compressions. Workpiece to reduce the cross section and increase the length. It is also called as incremental forging. In steps, we increase the height or decrease the height. It is called as incremental forging. The process is called as cogging. So, it can keep hitting and moving. So, this is the starting thickness, final thickness, and here the dashed lines indicate the next compression. So, this is moving. Closed die forging or impression die forging. In impression die forging, you see very clearly that there is a volume of material kept in the center. So, this is a die on top, this is the die bottom. So, when the compression load is applied, you see here there is material flowing along the land to the gutter, right. So, these things are called as flash, or also called as closed die forging, is performed with die that obtain the inverse of the desired shape of the part. So, you keep this, press this, you see, and here you see the flash. The flash will be removed and then you get the final part. Okay. Flash is formed by metal that flows beyond the cavity into a small gap between the two flat plates. The flash is very important. If there is no flash, there is not much of proper filling of the material, because there is a friction, the realignment of the material flow will happen and every portion is filled here. Flash indirectly helps in close and complete filling of the die cavity and is also increase the amount of the compressive force. So, this is very, very important. Gutter and flash are very important. A flashless forging is also possible. So, in flashless forging what happens is, you have a punch, you have a die, right, and then when the punch tries to hit the material itself fills all the area around and there is no flash here. So, in flashless forging, the raw material is completely contained within the die cavity. There you will have top and bottom. So, parting line decision is very important. Here the parting line is different, you do not have a parting line. In this operation, work volume must equal the space of the die cavity within a very close tolerance. So, whatever you need, so we try to make the mold here, put the component, hit it here, it tries to fill and get the material. Too large or too small blanks may result breaking the die and press or incomplete filling of the cavity respectively. The flashless forging is also classified as precision forging process. So, if at all there are any features, the features will be exactly filled and you get a fine control over the output. Suitable for simple symmetrical part and to work materials such as aluminum, magnesium and titanium alloys are used here. The other upset forging methods are, as I told you, the bolt can be done. Upset forging, what we do is, we try to have a feed. This is done by automatic machine. There is a feed which is there. There is a stopper. Feed comes from a bar. The material is fed inside. The material is fed inside the die and you put a stopper there. So, this is a stopper. So, here now what happens is, then comes the two dies. So, if you see in the next step, the top die, bottom die grips the bar, right. Then the stopper goes away, and once the stopper goes away, there is a free hanging bar here. Now, there is a punch there, this punch impacts on the bar. So, when it impacts on the bar, there creates a head, and this head, when the punch is pushed inside, the material filling happens and you have a forged head in place. So, upset forging, also called as upsetting or also called as upset forging, is a deformation operation in which a cylindrical work part is increased in diameter and reduced in length. It is widely used for making nails, bolts and other similar hardware. So, nails are also made by this way. So, instead of I said wire, we are using it for nail. If you replace it by bar, you can use it for bolt. Swaging and radial forging. If you want to have uniform reduction in the diameter, then what happens? You push the workpiece into a die, and in a die there are impact loads which keeps hitting, and that will try to reduce the diameter uniform. So, this is the starting diameter, and here you see there are dies and this is a workpiece. It is fed through this direction. So, this is the starting diameter, this is the ending diameter, right. Here the impact load is done on the die. So, here the workpiece is also rotated so that you try to get a uniform cross section. So, this is what it is. So, if you look into it, there will be a radial dies and there will be a cam. The cam will be rotating. Each time when the cam comes in contact with the die, it hits the workpiece. It is a forging process which is used to reduce the diameter of a tube or a solid rod. It is often performed on the workpiece, on the end of the workpiece to create a tapered surface. So, you can try to have such cross sections by using swaging, or you can also have a sharp tip by having swaging process. If you want to the flask internal surface, this is also done by swaging process. So, initially it will be like this, right? It will be like this. Now, you do swaging and you try to reduce this diameter. It will be like a bottle. So, swaging and radial forging is an interesting process which is part of closed die forging. Then you also have something called as roller forging. So, I roll using a roll, two rolls, and then the roll shape is given a special shape. When this roll rotates, when it tries to hit at the workpiece, it creates an impact. So, that is why it is called as roll forging, right. So, this is the workpiece, this is the roll has the shape whatever it is, and then it can create the shape whatever you want on the workpiece. Okay. This is the side view you are looking from here. This is the end view. Okay. When you see the end view, you can see this is the workpiece and you can see the guide flange whatever it is. Okay. Orbital forming is another interesting process. In this process, the deformation occurs using a cone shape, upper die that is simultaneously rolling and pressing the object. This will roll and it will impact. So, you see here, this is the orbital path. So, it goes like this, and then hits it. So, you can try to create parts like this. So, this is the lower die, this is the upper die rotates like an orbit and also hammers. So, you can try to have such interesting workpieces made out of orbital forging process. So, contact area between the upper die and the lower die you can see here. Hubbing process. In this process, a hardened steel form is pressed into a soft steel. So, this is work, this is a hardened steel, this is a soft workpiece. So, the shape is given to the workpiece. In this process, a hardened steel foam is pressed against a soft steel, so that it tries to create the shape. The process is often used for making mold cavities in injection molding and die casting. Trimming is the other process used to remove flash on the work part in impression die forging. So, trimming, so you keep the workpiece, you punch, you hit it. So, now the component is cut here. So, then the component falls down. So, you use this component for your real time application. The flash is trimmed, used to remove flash on the work part in the impression die forging. Forging also there are lot of defects. So, these are the defects. So, overlap is a defect which the area of action is crank, pin and web. Remove deformation of blocker die by dressing with template. Underfilling, you should try, the action taken is temperature, die deformation, delay, die pressing and lubricant. So, these are all action to be taken such that the filling of the die happens properly. Pitting are nothing but scales which are formed because of metal to metal friction, right. And then foreign objects, unwanted material and chipping, the oxides which form a hard layer and then it is formed here. Then shop scrap is the action area is temperature, the first zone temperature to keep higher side for a better soaking. Delay is prevent maintenance of conveyor and other things. Billeting is place the billet properly at blunder and check billet to touch the stopper and the flange side. So, these are some of the defects. These are the area of action. These are the corrective actions which are required such that we remove the defects which is there in forging. So, before we recap this lecture, I would like to give you a simple exercise. The exercise is, you will try to make a die. Okay, you will try to make a die, assuming that this die is made out of plaster of Paris, right, or wood. You carve and then you make wood, right. Now, what you do is, you try to take a soft material, okay. Let it be clay, then let it be some vegetable which is having a, and then third one is, you try to have some another clay is one vegetable, then you can try to have silly putty, which is used for sealing the glass windows. Try to take 3 of them, okay, or you take M seal. Now, you try to take a die which is made out of plaster of Paris. In this die, what you do is, you try to give impression. Now, you try to press this as against 3 of these work pieces. Now, you remove the die and then allow this fellow to cure and then see what is the amount of shrinking which is happening in the final impression what you have created there. If you do this exercise, you will try to understand the forging, how important the workpiece and the impact force is, right. Then the next one is, I would like to say, you try, you have seen many a times in the trucks where when they wanted to remove the tire, right, when they want to remove the tire, they always put spanner and then they put a long spanner, whatever it is, and a person jumps on top of it every time. So, my question is, why does he jump? Why do people not pull it around? He goes, stands on top of it and he jumps. Why does he jump? While doing so, what happens to the nut and bolt contact, whatever is there? So, if you understand this, then you will understand what is the effect of impact load. So, in this lecture, we have seen what is forging, classification and mechanism of forging, process in forging, open die forging, closed die forging. Then what are all the processes of different processes of forging, then analysis with and without friction, then operations of rolling and forging together. Finally, we have seen the forging defects. Friends, we have used this many references to prepare the slides, and the exercise whatever I have given is only for your self understanding. Thank you very much.